Well, hello everybody, and welcome to Skyter Livestream for this wonderful evening. I'm your host, Mark D'Antonio, you know, that crazy guy who's always around. It is Wednesday, the 13th of September, 2023, and we will be looking at the night sky in Arizona once again. It should be a really nice night. I haven't seen any problems, and you know, if you have a mind to, you can check out everything we have to offer. You can go to the Etsy Sky Tour shop. You can go to skytourlive.org and check out all the stuff we have. Remember, we are a not-for-profit organization, so we don't really make money anyway in particular. So, however you can help us, it's great. Join our Patreon. We got a lot of, I say a lot. We don't have many, but we have a number of Patreon subscribers that are really loyal and stick with us. All right, amongst these folks right here, as you can see, John P. Izabela M, Ollie B, Chip McCyber, Vera C, Ronald T, Martin W, Raymond B, Cindy M, Susan W, Diane H, and JSCO 77. So join us if you can in our Patreon. That would be cool. Hey, Mindforked, how you doing? I know you. Well, I think we did a good interview, you and I, together at this last conference they were at. I want to say hello to everybody that's here right now. We've got Renee Cruz, who was first, carrying on a nice conversation with Daryl, and then we've got Rockstar is with us. Rockstar, and RJPX is here already, and I mean people are trickling in, which is kind of cool. And Daisy and Zoe Amethyst are with us. Hi guys. Papa Tom is with us. Nice to see you as well. And I think that we, well, Jessica, hey, Jessica S is with us as well. That's cool. Nice to see you. Oh, maybe that's a good idea. Hold on, let me actually bring you in. I know, as always, one thing I forgot to do, but, you know, it's because I haven't streamed in a week or so. Of course, we have Daryl Mason with us. Hello, Daryl. How you doing?
Hello, Mark. I'm good, thanks. You? Hello, everybody.
I'm doing fine. I got caught up in trying to just make the early announcements and then forgot to just drop you in. What can I say? I do that once in a while. Not good, but hey. Anyway, welcome, guys. Yeah, we are going to explore the night sky. And I think since I use this object here, we'll use it as our topic for the moment, just to check out the quality of the sky. Okay, This, of course, is the Lagoon Nebula, Messier 8. And the Messier 8 is a really nice object that is what we call a stellar nursery. And as a stellar nursery, it is a place where stars are being formed. However, it's not it's also called a Lagoon Nebula. And it's actually a nebula that's powered by this little star right here. See my arrow right there? That little, in that circle right there, that little tiny thing. That is an O-type star, very, very hot star. So what we're going to do is we'll start with this one tonight because we're actually down in the southern Milky Way, getting a good look at it before it goes for good. And it's going fast, as Daryl has pointed out.
Oh, there's an interesting thing happening right now this time of year. Happens every year about this time.
Oh, I think I know what you're going to say.
Can you go to Stellarium for a second?
Yeah. All right. I'll back out.
Yeah, back out so we can see Scorpius.
Yeah, it's over here.
We were talking earlier this summer how Scorpius and Antares there seems to come and go really quickly in the summer sky because it's so far to the south of the zodiacal constellations.
Yeah.
But interestingly, this time of year, if you tend to go out about the same time after dark each night, Scorpius and Antares will appear to hang up in the southwestern sky for several weeks without moving much at all, if you go out the same time each night. And why it's doing that is it is still moving to the west, but because it's getting dark earlier every night, that we're actually seeing it a few minutes earlier if you go out after, say a half hour after sunset each night.
Yeah.
So it appears to hang there in the southwest for a few weeks. But it's still going away. But it's sticking around for a little while so we can enjoy it one last time.
That's right. Yeah, very cool. And of course, this is the Milky Way in Stellarium. And we, as you already know, we changed cameras. This camera that we're using now is a lot denser in terms of its array size, meaning that we can pack more pixels in a little square area, so we can zoom in more to objects. Hello, Sam S. Renee Barretts, how are you? And what happens is when the camera got changed out, we had a little issue with the fact that the whole lens assembly on the end of the telescope, if you watch me down here in the lower left, the whole telescope lens in the end got twisted just a little bit compared to the mirror. They're supposed to be perfectly perpendicular to each other. One goes this way, okay, one's supposed to go this way, and one's supposed to go that way. And unfortunately, the mirror and the lens are torqued just a little bit out of 90. So we have some star images that aren't that pretty right now. And we have Starlink too going through. And so the images are they're usable from a distance, okay? So as long as we treat this camera like we treated the past camera, which is also very good, then we'll be okay. So that's what we're going to do tonight. I focused it as best I could, but it's going to have a little bit of an issue, but it's not going to take away from the beauty. And just to prove that, what I'm going to do is I'm going to make this a 25-second exposure of the Lagoon Nebula. All right, and we're going to drop out of our mode here, the green mode, which is our night vision mode, and go into a live stack to show you what I'm talking about. Okay, so our live stack right here. If you look down the lower right corner over here where I'm using my arrow keys, you can see that actually is where the progress bar is. When that gets full up to the right side there near the numbers, our first exposure comes in. And then you'll see it right here listed as the number stack. See, this says 1. Look at that. Wow. That's pretty. And I actually have to zoom out in order to encompass more of it. See, this camera, it has a smaller field of view, but more pixels packed in there. So that means much higher resolution, relatively speaking, and that's good for us. Hey there, Fantasy. What's up? So we're okay, and this is really pretty. So we're gonna just process the nebula a little. Look at that. And then let's color correct. It's going to get a little less red, but that's fine. And we'll zoom in on our axes down here, which we use to do some processing. So you see, this is the data right here, that's down there on the right. It's all the data coming in from the camera. And this yellow line is the line passing through the data. So everything we see is under this yellow line. So we're seeing this, right? And we're seeing just the edge. If I was to move this line right here a little further to the right, you'll see that it's getting blacker and blacker until we're left with very little except the brightest, most bright parts. Mindfork, thank you. She's a sweetheart. She's you got to check out her channel. Put up your channel, Mindfork. Just, I don't think you can put links, but spell it out. And then if I take this right here, let me actually just bring this back to a level of moderate workability here. There we go. So see, when you actually reduce your black level, you see fainter detail, but you get a brighter background. Right? So you want a happy medium between where you manage the dark and then this middle one. Okay, this is the one that's going to brighten things up. But as you brighten things up, see, it could make the center get lost and overexposed. However, you see more detail down here that you didn't see before. So it's a trade-off. So what we do is kind of go somewhere in the middle, which is just about here, maybe just a little bit in like that, you know. Yeah, Mindfork says, thanks, Mark. Just glad I made it. I am too. I am so glad you made it. I'm glad you saw the announcement and just decided to drop in. I did announce it in Facebook on Skyter Livestream Facebook group and under my Mark D'Antonio Facebook ID. This is nice. Oh, you have no idea how much I can't wait to get out there next week. Michael Hedrick's with us. How you doing, Mike? Good to see you. C&D boy, hey, how you doing? Very nice to see you. Okay, let's hang on there, Daryl.
Uh-huh.
Yeah, hang on a second.
It's not my fault.
I know. Hey, Rock, thank you, man.
Thank you, Rock.
Yeah, we have a great community, you know. These folks, they take good care of us because you and I and Marianne and Tara try to take care of them, you know. Oh, yeah.
We would be nothing without our friends in chat.
Yeah, is that true? Fantasy says, hey, Mark, I'm curious. Do you need permits to build the structures in Arizona? In my county, you need one for anything over 120 square feet. Aha, that's exactly right. And same thing here, same thing in Arizona. So we keep our structures small so we don't have to worry about that. Exactly so. And our next structure that we're building is a beautiful clamshell enclosure that's going to be only as big as the telescope and its mount. And it'll hold the computer, the telescope, and its mount. So to work on the telescope, you literally will be outside the structure once you open up the petals, like the flower petals. And I'm using linear actuators to do that one. Now, it's not because of any other reason that we want to get access to more sky. Right now, if you look up here, you see the building has walls. Those walls actually impede the view up to a certain amount. On that side over there, things have to be above 41 degrees to see them. On the back side out there, they have to be above effectively Polaris. All right. And so at the southern side, they have to be above 25 degrees. On the western side, they have to be, I think it's above 15 because it's a little farther toward the west. I originally mounted this telescope to the right of center in here because a second telescope I was going to put right over here next to it. But I realized that that's not a good idea because, yes, it'd be great to have them there, but that's too small a building for two telescopes. I'd be cutting off views. So we're going to opt for making small enclosures for each new telescope we put up. And those enclosures are going to open up and showcase the entire sky to the telescope. The downside of that is that if it's a windy night, we're going to see more wind than we would with a system like this. But the idea is that overall we'll be able to manage, and I think it's going to be just fine.
Life is full of compromises.
It is. Hey, Cyclone.
Didn't you originally intend to put 3 telescopes in that space?
Yes, we were going to do that, and one was going to be kind of like a very wide field system, piggybacked on another, but we were going to do an equilateral triangle setup in there. But it turned out that I had to compromise on the size of the building for reasons we just talked about, and because of that, it dropped down to 2, and then I decided I'm gonna actually do just the 1, and we actually are gonna put the next telescope enclosure on a wholly different piece of land. Again, it doesn't belong to us, but is literally 2 miles from this one in the desert. It's a gorgeous location. The sky is gorgeous. Believe it or not, 2 miles away. If you look at the light pollution impact there, it's like 0.03 better 2 miles away than it is where we are, and this is great. So I don't know, it's just amazing. Yeah. Mindfork says, this is one of the coolest things out on YouTube, watching the stars with our brilliant tour guide. Well, tour guides, plural. I don't know that she met you yet, Daryl, but Daryl's with us too. And Daryl is another astronomer, friend of our Sky Tour family who joins us on our streams. And he's full of wonderful insights that, I don't have because we play off each other in astronomy and versus my astronomy and Daryl's astronomy. Together, we make a reasonably competent astronomer.
You say so. You'll miss me when I'm gone.
I don't know. Don't be so sure about that. The more you say it, the less I will.
Oh, well.
Yeah, right. Hey, Tim F. Woohoo, you got it. Okay, so we have done 20 frames already. You'll notice the guiding is excellent. So what I'm going to do is I'm going to save this. It's already listed up there in this name. You can see Lagoon Nebula. And when I hit save, for those that may or may not know or remember, you'll see it's listed here. This file is going out to our server, and that server is also a place that you can go and grab this picture. All right, and it's free. And here's what that picture is on the server right now as we speak. All right, there it is. It'll be up on the server. It's left the observatory, gone up to the cloud, and gone down to our server, which is available here at skytourlive.org. You just scroll down at our website, and the second panel down, it says, hey, I want to check out cool pictures. And if you actually want some of these pictures, scroll down one more panel, and it takes you to our darkroom site where you can actually buy these on canvas, on metal. I mean, 100 different options. It's fantastic. All right. And then if you rather just buy products that have them like on mugs and blankets and tote bags and luggage, well, then you can go to our Etsy store, SkyTour Shop, and get them there. All the money goes into our nonprofit to help us keep doing what we do. I sound like a CPTV, a public television telethon, don't I? I think I'll stop now. Alicia Vieras, how are you? How are Darlene and Donovan doing? It's so nice to see you with us tonight. Oh, thank you, Daryl. Daryl put up the link, as you can see in our chat down there. You can see what he did. Right. Okay, so let's save this one more time, and then we'll move on to the next item up for bids on The Price is Right. Okay. So, what's a lagoon if we don't show the Trifid Nebula as well? So we're going to go there. So what we do first is we're going to go back to our night vision mode here. And you'll notice there's like a little delay in the movements, and that's all because of the fact that it's a 1 second shot. See 1,000 milliseconds up there? Okay, this line here, the exposure time, and then this one down here, the gain. All right, these are the two most important numbers here. The gain is the sensitivity of the sensor, and the exposure is how much time we're allowing stuff to fall on that now sensitive sensor. All right, so, and up here you can see our numbers. This is the computer into the telescope, so we can see what the telescope is thinking, doing, and contemplating. And then we have our beautiful, this is Stellarium, which is our actual telescope steering mechanism. I connected Stellarium to all of this. So we're going to go to the Trifid Nebula here now. Now the Lagoon Nebula is red, okay, and that red color is due to ionized hydrogen that glows red. All right, and there's the Trifid right there. And there's another color associated with nebulae, which many of you are aware of, and it's blue. And the blue color that we'll see from time to time is due to dust particles. The black lines you see here are dust lanes that are obscuring a brighter nebula behind them. We see that all the time in astronomy. These silhouetted objects are just everywhere. In the lagoon, you saw them. Okay, like if we look at the lagoon real quick again, I'll just bring up this last shot. That's just too bright. 1 second. Okay, see these dark lanes, these dark nebula? These are all in front of the bright nebula behind, and they actually literally form, these particles form shapes of tendrils and so forth that you see. And sometimes they look like they look like here in the Trifid Nebula, where they have dark lanes. Now we'll center this up here for a second, and then we're going to take a nice exposure of this as well. Head to the west as well, just a little bit. There we go. And then it says searching up here because it's actually, we have a telescope that has two telescopes in one. And there's a telescope on top of this one. It's out of the view right now. It's because it's above it. And that's a guiding telescope, which is doing all of the guiding for us. I'm going to head over to the west. Cyclone has a question.
Yeah.
Did you answer him already?
No, I asked him to clarify.
Okay. If you made a telescope to a 1:1 scale of our galaxy. Oh, I see what he's saying. In other words, if you had a telescope the size of the galaxy, the resolution would be stupendous. I think that's what he's saying.
I guess. Practically it'd be unworkable, but I mean, if anything could see all the way there is, it would be a telescope the size of the galaxy.
Yeah. Agreed. Okay. We're stably guiding right now. I might have mentioned this before, but you see these numbers? These numbers need to stay below 1.5. If they stay below 1.5, then it's going to be a good frame, because that's the guiding. If it goes into 3 and 4, it means there's some wind. we had that the other night, the last stream, and in fact, a lot of these had to go. We had to let them go. Okay, let's let this get back to doing its thing. All right, and then we'll say a 25-second shot here as well. Okay, off we go. Out of night vision mode and back to the lagoon, which is in our buffer, which we're going to clear. Okay, you see our yellow progress bar. We're almost ready to see the first of the stacked images. Here's the first one coming in. There it is. Wow.
Nice.
It is. Now you see that it looks kind of grainy out here. That's because that's a single image. When we stack the second, and the stack is taking the next image and aligning it with the first, making sure the stars all line up with each other, and adding the data together, and you make an image sandwich that way. And so that's possible, you know, and that will reduce the noise, because the noise is it's stuff that's occurring randomly. And when you put together a lot of frames and you add up all the noise, it averages out to 0. And when you add up, or to some level, and when you add up all the data, like this little piece of dark nebula over here, okay, this dark dust cloud, it averages to a much higher number because we're getting just that data, and it's getting bigger and bigger and bigger with each frame. So the more we stack, the better we see, the more detail we'll see. Now, we actually, if you want to see even more, what we can do is pull this black level back, and you'll start to see there's even more out there. All right, and if I color correct, all right, now you can see there's red in throughout all of this region. This is a beautiful region, and it has all this emission, this diffuse nebula from this region of space. There's a lot of hydrogen, the most plentiful element in the entire universe, and this stuff can be caused to glow by hot stars, like the ones causing this hydrogen to glow in this area right here of the Trifid Nebula. There's these dark lanes here, like that. Like I said, you'll notice this one. I mentioned the blue color. Well, again, this right here is dust that's actually scattering the blue light from stars in this region, possibly this star right here. And when I talk about scattering, here's what I mean. We know that light comes to us from a star in all colors of the spectrum: red, orange, yellow, green, blue, indigo, and violet. And when the light is hitting a dark dust grain in space, which are only a micron or so across, these dust grains will take certain parts of the spectrum and absorb the light and then re-emit it in every which direction. And that tends to be high frequency light. So the high frequency will get absorbed and kicked out, and the rest of the light will be allowed to pass through. So our atmosphere does the same thing. We've talked about this many times, and that's why the atmosphere is blue, because the molecules and particulates in our atmosphere are scattering the high frequency light from the sun. When the high frequency short wavelength light is blue. So same principle applies. It's called Rayleigh scattering, and it applies here in space with this nebula right here. This is really a nebula caused by a scattering process where the light is scattered, like I just mentioned. Now, if you look at this, you'll see that this blue goes all the way around this whole region. See that? There's subtle blue over here. Not bad for only 8 exposures stacked. So see this already. And if I pull this in, then you'll see a little bit more. And if I darken the background somewhat, you can see it even better under higher contrast. Whoa, what was that?
That was probably me.
Okay.
I don't know what it sounded like.
Like, psh.
I took a deep breath.
Oh, well, you don't have you're not, you're using the microphone, right? That we got you?
Uh-huh.
Huh.
I think I was leaning toward it when I did it.
Oh, okay. Yeah, it's a very,
Sorry.
no, it's fine. It's very sensitive. I wanted to make sure. It almost sounded like static at first, and that made me worried that something was wrong. Okay. All right, so there, that's pretty cool. So, um, yeah, so I'm studying the star images and looking at things this way. So, trying to figure out what we can do to improve things once I'm out there. I'm 10 steps ahead. Sorry, guys. Fantasy says comets are made of ice. I think he was, and the moon has ice. Yeah, that's true. Um, the lunar craters that are in perpetual shadow, like at the south pole of the moon, they have water ice mixed into the lunar soils. And so they figured, well, they have to do a colony. They're going to do a colony near the South Pole where water is available. However, it turns out that water is not just at the South Poles. It's also elsewhere on the moon, on the day side of the moon and the night side, which is obviously not always day and night, right? Because all parts of the moon will get light because the moon is going around us like this in a fixed manner. So, from the sun's perspective, the moon goes around once on its axis every time it goes around our planet, approximately.
Once a month.
You got it.
Once a month.
Once a month. So
It's
Cyclone
not a.
talks. Okay, sorry. Go ahead.
Nothing. Carry on.
Okay. All right, Cyclone asked a question early. Hey, Alice Pooper, how's it going? He asked about extraterrestrials or something like that. And 12 feet tall says, why does space exist? That's a good question, too. I will get to that. I'm just looking for Cyclone's question he asked earlier. Okay, okay, here it is. Is it possible for extraterrestrials to be billions of years more advanced than us? Well, I guess anything's possible, Cyclone, but the question is, what makes an advanced species and how long does it take? Now, when we think about life on other worlds, we have to consider all the many possibilities and what may happen to life on another planet in terms of extinction events or whatever. Here on this planet, we are just as we are after 4.5 billion years of the planet existing, after 5 major extinction events. All right. Well, if there was a planet out there that had one major extinction event early in its history, well, then it's possible that there could be a civilization that is 1.5, 2 billion years older than we are. And what would that look like? And that's the question. And that one is always speculation. We have no idea. You know?
I'm having a brain lock here. What's the term? There's like a great thing in the way that life may not be able to get past.
Oh, I know what you're talking about. It's okay. I'm having the same brain lock.
Uh,
Yeah.
I've seen it many times. Kurt talks about it. There is some people posit that there is a barrier somewhere ahead of us that any sentient species, I guess, might encounter sooner or later that is going to stop them in their tracks. The Great Filter. Thank you, Fantasy. Yeah, it's called the Great Filter. That
Oh, that's I remember the term. Yeah, um, I was trying to think of a specific set of hurdles. Um, the gray filter is a generic term, though, for a catch-all for things like, I mean, an extinction event is a filter. We were filtered 5 times and we still survived. You know, but I know the term. I don't see. I don't really subscribe to that. Um, I think that comes from people that want to try to posit that there is no intelligent life other than us in the universe, and if there is, they're so far away they could never hope to come here. I don't believe that at all. I think that's actually not true. I think that there's life elsewhere, and I think that they're actually relatively nearby. Now you look at, and the reason I say that is you look at the stars that are relatively nearby. There are a plethora, many, stars that are nearby that have the potential for life. Just look at this latest finding from the James Webb, which is controversial, and more has to be done. But it looks like they found sodium dimethyl. Was it dimethyl sulfide or dimethyl sulfate? I can't remember.
I believe it was sulfide.
Yeah, dimethyl sulfide, and in the atmosphere along with some methane and water. Now you might say, "Oh, we can't breathe that," and that's true, we can't. But there are microbes that do, and our planet looked like that years ago, billions of years ago. There was no oxygen or carbon dioxide on this planet when we first formed. The only atmosphere came from expulsions of gas from volcanic activity on the planet. None of that stuff was life-giving gases, okay? But to a microbe, that wasn't a stopping point. Microbes feed on methane. Just witness what happened when the Gulf of Mexico, when the BP blowout occurred years ago. Millions and millions of tons of methane and crude oil blew out into the Gulf of Mexico. And we heard people saying, oh, the Gulf is going to die. It'll never be the same. There'll be dead zones from the methane. And what happened? Less than a year later, all the methane was gone. Why? Because the Earth has developed mechanisms for handling this. It developed these microbes that, evolved on the planet to take advantage of booms in this methane. And when these methane-eating bacteria sensed more methane, they reproduced more. And we got trillions upon trillions of these little bacteria, which began to eat the methane. And so successful was it that the Gulf was cleaned of methane in just a short time. And that dead zone, predicted by a couple of scientists, turned out to be not so dead after all. And they've since retreated into the background where they belonged in the first place. Not thinking that the Earth is managed. And all they had to do was look at our oceans now to be able to say that this might have happened. Why? Because there's natural oil that seeps into the ocean from the ocean floor all the time, to the tune of, I think it's like several 100 million gallons a year of oil seeps into the ocean. And the Earth has developed a way to handle it and get rid of it. From microbial action to tar balls that are formed by this oil. It rises to the surface, but then it sinks to the bottom, wraps up in the sediments, and gets reabsorbed into the sediments and recycled. It is a hydrocarbon, after all. So that said, this process is something that has been going on. Now, had it not been going on, had the Earth not had a way to deal with oil leaks like this, then guess what? You'd be looking at the ocean and having to wash the oil off your body every single trip to the ocean. Because the ocean surface would have an oil sheen on it. That's how much oil has seeped in over a few tens to hundreds of millions of years here. So honestly, the Earth develops mechanisms to fix the problems. So I'm I'm not a. That's part of the reason I'm not a fan of the Great Filter, because I think that as far as the planet goes, even though Earth is not the most hospitable planet, and I did say that, and I mean it, although it's not the most hospitable planet for our kind of life, I do think that life like us can be tenacious enough and has been tenacious enough to survive and develop. And don't forget, intelligence is not a foregone conclusion or a destination. It's one potential twisty, curvy path. So there's going to be plenty of planets we find where the animals are probably no smarter than dolphins, which is not to say that it isn't smart, because it actually is. Dolphins are as smart as a very smart animal, a dog, you know. So as far as that goes, they're just in the sea, and they look the way they do because their evolutionary pressures never resulted in them having to do anything more than just what they do now in the oceans. And Marianne Robb is here. Hey, Marianne, how you doing?
Hi, Marianne. It's interesting to contemplate the question, as I think it was. You said it took us 4.5 billion years to get to where we are now.
Yeah.
But if the universe is 13.7 billion years old, or nowadays Webb supposedly says it's 26.7 billion years old,
Yeah.
there was plenty of time for others to come before us. Somebody had to be first.
That's right.
Are we the first? Are there races still living out there so far in advance that we might not even recognize them as life? They'd be like creatures of light and magic.
That's right.
It's like Arthur C. Clarke's old saying, sufficiently advanced technology would be indistinguishable from magic.
Magic, yeah.
That's like we would have no common reference frame to even recognize them or to be able to relate to them, or
That's right. That's right.
Who knows?
Yeah. I wanted to reference something Marianne's mentioning in the chat. Some folks have asked for a list of the equipment, cameras, and everything that makes up what you see here. And I'm going to put that out on Facebook at some point, yes. We're not trying to hide it. There's no reason to. But I will say, if you want to try and remote a telescope, let's talk, because there's a lot of pitfalls, a lot of things that go wrong, and you have to be able to focus on a camera. See, you have to be able to get past those. I can help you with those hurdles, but I'll go over that with y'all. All right. Renee says Rocky Boris bad enough. Is that a response to a Bullwinkle question?
Yes, Bullwinkle, sure.
Oh, okay. Hey, Bullwinkle. Natasha, we got to get moose and squirrel. Boris, darling. Darlink, remember?
I was pondering something the other night, and I don't remember what made me think of it. This might not even be the place, but if you were a photon, okay,
I beg
you're
your pardon?
traveling at. I'm sorry.
Said I beg your pardon?
You're traveling at the speed of light because you have to. Photons travel at the speed of light.
Mm-hmm.
They cannot go slower than the speed of light. At the speed of light, time does not pass.
That's right.
From the photon's point of view. So whether you're flying from the sun to Earth or to the moon in 8 minutes, or you're flying to Alpha Centauri 4 some odd light years away,
Yeah.
it's instantaneous. Time does not pass. And I was trying to get my head around this the other night, that, the universe from the photon's point of view, no time passing. I mean, you can get to the moon or you can get to a galaxy on the far side of the universe in the same amount of time, exactly zero time. And I guess first you'd have to posit that, life could exist in a photon sort of idea. I'm not even sure what I'm getting at. I'm trying to get my head around it. Do you see what I'm saying?
I do. You're saying that if we were as observers, okay, let's look at two reference frames. That's what we call these reference frames. If you look at one reference frame, which is us on the Earth in regular time, and we're looking at a photon that's actually composed of a spaceship with a window, and you see somebody in there, and they have a watch on their wrist. Okay, from our point of view, for all of eternity, every time we look at that through that window with our very powerful, amazing telescope, a relativistic telescope, we'd see if the time was 11:15, we'd see the time would be 11:15 from our point of view for the entire time that this ship was visible to us as it traveled from the farthest point from us to close to us to the farthest point away from us. So the time would be the same on that watch at the speed of light, right? But if you're in the ship, the amount of time that passes when you just scratch your nose is an eternity. So it's a time dilation paradox that's related to the twin paradox, in a lot of ways, because the twin paradox posits that if you had two twin brothers, you put one in a spaceship, send him out at the speed of light somewhere, and when he comes back, he'll find that many years have passed and his twin is now older and gray, where he's still young and black or brown hair or whatever color hair. And it has to do with how far they go and and so forth. And it has to do with time dilation as seen from the Earth and as experienced on the ship. So what you're positing is not anything that is difficult to understand per se. It just doesn't make sense to ordinary humans because we've never experienced how time dilation occurs in any real palpable way, other than through people telling us that this happens this way.
But time dilation is detectable even on human scales.
It is, but not in any palpable way. In other words, in our ordinary routine life of growing up, going to college, and driving to work and back, and eating breakfast, and going out with friends, running an observatory, time dilation isn't part of our daily lives. So without living it in an obvious manner or seeing it in an obvious manner, it just becomes an abstract concept, which remains abstract to most people, even though it's happening all around them.
Could I address something Michael
Sure,
Hedrick asked?
Yeah, go ahead.
Do we have sufficient 3D images to know what constellations we would see from another part of our galaxy on an exoplanet? At galactic scales, Michael, I mean, there's always going to be stars in somebody's sky, and if they have any curiosity, they might connect the dots with them and make their own constellations. Somebody on the far side of the galaxy would not see our constellations at all.
Correct.
As far as 3D images or such, I have seen where how the night sky would look if, say, we were on Alpha Centauri instead of orbiting the sun. That we could see the local neighborhood from Alpha Centauri's point of view and see where the sun falls in that view. Does that make sense? Like what would be the constellation that would be behind us from Alpha Centauri's point of view? I have seen images of stuff like that, yes. But
And
on a galactic scale, our puny little constellations are all in our neighborhood, and they probably wouldn't be visible at all.
yeah, I will address this though. Sometimes we do streams where we show what it's like to go to the Pleiades, for instance, and look at other constellations and see how they change from that point of view. The 3D universe is out there, and it is calculated for a great number of stars and their locations. Now, there is an application out there you can download. I think it's $25. I got the professional version, and it's called Space Engine. And I brought down millions of additional stars for it and high detail imagery. So sometime on a cloudy night stream, we'll do Space Engine and go explore the Pleiades, circle the Pleiades in 3D, and see how they are related to each other, and see how from a certain point of view, boom, the pattern that you're so familiar with now shows right up. But then as you turn around it, you'll see how the pattern changes radically. And that, because it's all 3 space, okay, 3 space, 3D, it makes it very difficult to imagine how things look. Orion looks like a 2D shape to us. We have Betelgeuse, we have Bellatrix, we have Saiph, and we have Rigel in the other corner. However, if you start twisting Orion, to one side or the other, you'll see Betelgeuse is going to go wildly out of the way, because Betelgeuse is a lot closer to us than the other stars in Orion, which average around 1,500 light years compared to Betelgeuse at around 500 to 700. So we'd reach Betelgeuse long before we would actually get to, say, the belt of Orion or Rigel. So it's interesting how that all works. But again, every time you look at the universe, you're seeing it not only back in time, but in 3D. So you have to keep that in mind, that it's like this star's closer, this star's farther away. Okay, this one's really, really close, this one's really far away. And together they form this two-dimensional impression to us. I'm going to stop this now. I think
Izabela's here.
Oh, yeah, I noticed that. I forgot to say hi. Hi, Izabela.
He's here. Hi, Bonnie.
Oh, Anahata
Hi, Izabela.
77 is with us. Yep. Okay, so the Trifid Nebula is there, and it's saved out. We will be checking that out at another time. Now let's go back to our singular night vision frame here. And let's go back and check out our connected planetarium software. And let's do this. We're going to go right up here to this one. We're going to keep right going up the Milky Way here tonight. All right. And go to this object called the Omega Nebula. You'll see it come in here in just a second. Fuzz blur, there it is. The Omega Nebula is interesting. I used to find this nebula boring. I did, because I would look at it and say, the Omega Nebula, it's just a little splash there. It wasn't too exciting. And then I did something amazing to really change my view. I did a longer exposure of it, and I found all kinds of detail that I never knew was there. And so now it's actually become one of my favorites, and we're going to do a 25-second shot of this one as well. Just so you can see. Now we're starting to guide over here. You watch our numbers up there. All right, and once we start guiding, it's going to do, it's going to go from the zeros and start doing its guiding. And there we go. It's on its way. Looks like it's stabilized. It's little, yeah, it's going off once in a while, but we're going to try it. Give it a shot. All right.
Art, would you excuse me a moment, please?
Sure thing.
Be right back.
So the Trifid Nebula is up on the server if you want to just go check it out. You can download the picture right from the server if you want. And I'll be out there next week. Marianne asked me to remind you all. I'm heading out there next week from Connecticut. I'm literally going out from the 19th to the 22nd, so it's just a really quick trip. Oh, look at that. Look at all this extra stuff out here. I never knew it was there when I was looking at this in the past. And this will be a trip that will allow us to sharpen up our stars tremendously. So that's what this trip is about, is to get that done. And that sharpening process to make the stars perfectly round is called collimation. And it's really going to be pretty awesome. Cosmic Ray says, if the universe is expanding faster than the speed of light, we would not see a whole lot of the universe. Well, the universe can't expand faster than the speed of light. And I don't think that's what you're saying, Ray. But what's going on, actually, is the universe is expanding and accelerating faster, and it's possible that it'll accelerate to a point where matter is, say, a good fraction of the speed of light, and then we would never see that light, and so we would miss it, you know. So that is something that's possible. Now, when Daryl was talking about the universe being older than we previously thought, which is 13.8 billion years, he was referencing a finding by the James Webb Space Telescope. Well, that finding, because of the way the James Webb works, the James Webb could look back in time and see back to when the first galaxies were forming. And so we fully expected, as astronomers, that when we would see the first galaxies, that they would be in formation. We would not expect to see them fully formed after, say, 250 million years. We'd expect to see clusterings of stars and accretion disks and rotation maybe, but no fully structured galaxies at that time. Yet, that's what we see. We see fully structured galaxies only 250 million years after the onset of the Big Bang. And what's that tell us? Well, to be honest, it tells us that we don't know a whole lot about the universe after all. I think that the point being that the sorry, I lost my train of thought. I was looking in the chat. Darn it all. If Daryl was here, he'd remind me where I was. Someone in chat just remind me what I was just talking about. I'll get back to it. Oh yes, Michael, I'll talk about the you're talking about this dark patch here? Right there? Alright. I'm trying to remember what I was talking about. I don't know how that happened. I mean, I know how it happened. My head is like... I was talking about this guy. Yeah. I'm doing 5 things at once all the time. Universe expanding. Yes, I was talking about the universe expansion. Okay, thank you. That did it. Okay. So when you look at fully formed galaxies only 250 million years after the universe began, that tells us one of two things. Either we don't understand how the Big Bang occurred and how galaxies form, or the universe is a lot older than we thought. And so that could mean a couple things. That has a lot of repercussions. It could mean the universe is a lot bigger than we thought too, because it's been expanding for even longer than we thought, by quite a bit longer, twice as long. So right now we think the universe is 92 billion light years in diameter. Well, you'll say, well, wait, 13.8 billion years. That's where the cosmic microwave background is. Okay. When that cosmic microwave background light reached us, that was at the 13.8. It took it 13.8 billion years to get here from out there. But all the while that light train was coming to us, the universe was still expanding, and the cosmic microwave background was moving out as well. And on top of that, we find out that it's accelerating as it expands. So it's not just, say, double the length, it's actually even bigger. And it amounted to an amount that reaches 92 billion light years in diameter by the time we calculate for the continued expansion after that light has reached us from 13.8 billion years ago. And that same light, that light's coming in over and over. So, the light we see is a little further away than when it was first discovered, but on a human scale, that's not a whole lot of distance. So it means that we actually have a accelerating, expanding universe. The universe was thought to be 92 billion light years in diameter, and until more research is done, we're just going to run with that for now. I tend to think it's probably a little older than the 13.8 billion years. So we'll see where this takes us. That's a problem for cosmologists, happily, not astronomers. So we can just continue to do our thing and wait to hear what the cosmologists say.
And see how many angels really are dancing on the head of that pin.
That's right. 12 Feet Tall says, how do we know how old the universe is, and how do we know how old anything in space is? That is probably one of the best questions of the evening, and I have to tell you, 12 Feet, and thank you for that question. It's really cool. When we look at the universe, we know how old things are because we can look at the components that make them up. Like when you look at any one of the stars in this image here, we can take apart its light and see what it's made of. And if that star is made of elements that are elsewhere in our periodic table, we know that the star isn't making them. We know that the star was made with them. So in other words, from a pool of material that formed the stars, this star was made with all those elements. Our sun is an example. We have a special name for the spectrum of our sun. It's called the Fraunhofer spectrum, named after the guy who looked at the spectrum and said, look at all these elements showing up in our sun's spectrum. The sun is not hot enough to make magnesium, but there it is in our spectrum. It's not hot enough to make calcium, but there it is in our spectrum. Why is that? Well, it depends on how it shows up too. And it shows up as what's called an absorption line, meaning that the envelope around the hot core, which is the only place, that little marble inside the star, is the only place where fusion is occurring. All that brightness outside, that's just the plasma, the superheated atoms that have now been disassembled by the radiation into protons and electrons. That's just the plasma in that outer envelope. And it's, believe it or not, cooler than the very, very millions of degrees core. And so, being only some few thousands or tens of thousands of degrees, or several 100,000 degrees in that sphere of gas around the core, that's considered cooler. And when the hot radiation is going through that from the inside, that cooler gas absorbs some of the radiation. And what is actually absorbing the radiation are the nuclei of these other atoms, like potassium, like magnesium, okay? And these these nuclei will then, by absorbing it, will cause a dark line to appear in the spectrum that we call an absorption line. And there's a variety of isotopes of these that are easily picked out by looking at a spectrum. And so that's how we identify how a star is built and how old it is. Because if we look at stars that are extremely old, okay, and these are called population 2 stars, like in globular clusters, for instance, we'll see that all of the gas, for the most part, in these stars is made there's only hydrogen and helium, not a lot of other gases. What's that tell you? It tells you that those stars formed early on in the universe, before there were lots of a pool of materials from which the stars could form. Like in this image, some of the stars in here, guaranteed they have most of the stars in here have a very complicated spectrum with lots of elements in that outer envelope that are absorbing the radiation from the inner core of each of those stars and making these dark lines. So the spectrum are very complicated in these stars out here. But in globular clusters, they formed at a time before any of that pool was available. Now, where'd those come from? All of these additional elements come from the place where these dark nebulae come from. Supernovae. When a supernova explodes, it rips the star apart and scatters everything it made. The more massive the star, the more elements that can be made in its core at the time of supernova. And this type of process has taken place so many times that it's not even sensible to even count. So in our galaxy, we see lots and lots of exploding star locations. In fact, supernovae are being discovered all the time, actually. There was just one discovered just the other day, actually. And so when you look at an area like this, you're seeing it because of so many supernovae that occurred. This dust was once made in the heart of a star as atoms in the outer envelope of a cooler red giant that went supernova. And then it got scattered out there and combined with other materials to form molecules of carbon, silicon, and then water in interstellar space, which is readily available, started congealing on it and combining with it. And this ended up forming a lot of ice-coated dust out in the universe. And it's this ice-coated dust which is the fundamental foundation of life in the universe. And to answer Michael Hedrick's question from before, this dark dust then is sitting in front of this nebula. That's up here, and the nebula is behind it. Okay, it's silhouetted by the nebula. This dark dust then is the fundamental, foundational soup from which planets and stars can be made. Because there's certainly a lot of hydrogen in there. The hydrogen is all the reddish glowing stuff you see here. And it's actually even a little bit more red than we are showing here. But the hydrogen is certainly very, very prevalent, and the dark dust is very much too. In fact, dark dust is all throughout this whole region. You can see it all through here. This is all dark dust. It's not an absence of stars. It's dark dust obscuring stars behind it. That's what you have to think about. And it's not in every direction. You know?
But we do see the same processes happening everywhere we look.
Yeah.
I mean, when we look at the North American Nebula, we see the bright parts of the nebula, and then there's a big dark cloud cutting off our view from part of North America and the Pelican in between the two objects.
Yes.
When we look at the Rosette Nebula, we see something similar going on. Maybe without the big dark cloud blocking it in the middle, but we're seeing down into a hole in the bright part of the nebula in the middle of all the darkness around it, the dark clouds.
Yeah.
And Orion, you name it. We see the same processes over and over again wherever we look.
That's exactly right. Exactly right. And that's something that I think is, like I said, it's something once you understand it, you can actually really start to understand what's happening in the universe. It's really interesting. I love the universe. I can't get enough of it. That's why that if it's clear, I'm going to stream. Because I want to show you everything that's going on out there. And you got to keep in mind that, you know how we image the same object many times, like this one we've imaged before. Why do we do that? We do this because at some point down the line, you'll be able to compare the earliest image of this Omega Nebula that we did with the latest image we did, and see if anything is different. Now, admittedly, at such a long distance, you're probably not going to see a whole lot. All right. However, you might see that some of the stars may have shifted in position because some of the stars are a lot closer to us. And depending on where we look, you might actually see how a star has shifted in the night sky from the previous time we saw it. Right? So this is something to look for as well. And I say that because all the stars you see in this image are moving. They're all moving. Okay? And that is something that is very important to understand. Everything's moving in the universe. The gas cloud is moving. It's moving in a lot of directions at once. But there's no way to know which direction just by taking a picture night to night. You'd have to take pictures century to century to see the slightest movement. But if it's closer to us, you might see something. For example,
we've seen movement in the Crab Nebula.
I was just going to say it, yeah. The Crab Nebula is a supernova remnant, a very powerful explosion from a star that blew up, right? That's in Taurus. And over 100 years, they have actually seen the crab doing this, expanding. And there's a time lapse showing you the shots of the Crab Nebula expanding. So there is. And supernova 1987A. Okay, that supernova, we see the light echo, the light moving out and illuminating different areas of the gas cloud from within which the supernova occurred. You actually see that expanding light echo moving out, like ripples. So, interesting stuff. Okay, we'll name this and save it. Yeah, so I'm going to go out there and spend time with the tarantulas and the rattlesnakes. Okay, there we go.
12 feet tall, they're stars. Do they have planets? Hopefully. We can't see the planets. We can't. Big enough telescopes, they can see exoplanets.
Yeah, but only through inference by looking at what they do to the starlight, such as a transit.
Yeah.
Pull that out. We don't need that. It's the wrong one anyway. Omega Nebula.
They've seen planetary systems around some stars that are not transiting the star.
That's correct. The Gemini telescope was successful in doing that. You're right.
Yeah, Fomalhaut and
yeah,
some others, I forget.
Fomalhaut shows a large planet that is moving far away from the star. And it's actually sweeping out dust very clearly, which is kind of cool. All right, so let's go up here, check this out. So this object we just looked at, and the one before that, and before that, the lagoon, the Trifid, and the Omega Nebula, these are areas where we're seeing star birth taking place, right? And this is an area right here. This guy is an area where we're seeing stellar death, the end of a star. And in this particular case, this particular star was a star only either a little less than the sun size or maybe a little more, we're not sure. But we're seeing remember that outer envelope I mentioned that had all these different elements in it? Well, we're seeing many different elements in this because the stellar core effectively got so hot that it separated itself from the outer layers, and the outer layers slowly moved away from the star over time as the star died. There's a whole class that I do on stellar evolution, and it would take a long time to get through it. So, in short, when a star runs out of hydrogen, it's going to swell into a red giant. And in this particular star's case, when it shrunk back down, it began to pulsate back and forth. And as it pulsated, a little material, because that red giant was so big, a little of that material became free of the star's gravity and just floated away. So we're seeing these pulses here. These are pulses. This is like north and south on this star right here, and this is like the equatorial region, I believe. And so the star was spinning. All stars spin, some more rapid than others. And so it turned out that much of the material was sloughed off along the equator here of the star. And that's why it kind of looks like an apple core, as Daryl has pointed out before.
Maybe you should start doing a stack.
I'm going to. That's what I'm about to do. And the name for these are planetary nebula, so PN. And this one, we're only going to do 15 seconds because 25 seconds is actually too long for this. Alright. Alright, and we'll get back to our Omega Nebula. No, don't change it. And then we'll just clear this. Renee Barron says we had a heavy rain here today. And it flushed a baby tarantula out of the ground. It's the first I saw all year. Interesting. Yeah, I had it under the computer out in the building. And it was really cute. And one of the husbands of one of Tara reached down and just let it crawl up on his hand and up on his arm. And he took it outside and kind of gently brushed it off so they could work in the observatory without worrying about a tarantula. All right. So
I forgot to mention earlier, Ray posted an interesting link to a short video of the Webb telescope looking at the Trifid Nebula.
Very cool.
It was really cool.
Yeah, so after the stream, guys, just go back through the chat and check out some of those links. I want to say hi to Gladys. Hi, Gladys. Karen Model's with us. Hey, Karen. I remember meeting you out in Roswell, I believe, right? Anthony DeSanto, how are you? Yes, you called it the Christmas tree ornament nebula last time. Yeah, this is actually Measure 27. It's the Dumbbell Nebula. Not a very exciting name for something that looks like a Christmas tree ornament, I grant you. And these M names, and that's because Charles Messier had cataloged a lot of these objects. All right, and we'll just put this up now. Bing. So there you go. So this is the Dumbbell Nebula. And Dumbbell is spelled in this case 2 B's, 2 L's. All right. Let's actually... I want to do one thing here. You see that little tiny dot? You can't see it that well. Let me reduce the brightness in the core of this. There we go. So right there, you see that little bright dot right there? It's actually blue. Okay, that blue dot right there. That right there is the central star in the Dumbbell Nebula, that bluish dot. It's blue because of the fact that it's a white dwarf, and it's exceedingly hot. So that hot white dwarf is ionizing the oxygen and turning it green. It makes it glow green, and the hydrogen and neon and other materials in the outer areas here making them glow red. Now, there's certainly hydrogen being ionized within here, but the oxygen content is overwhelming the hydrogen that we can see. You can start to see a little bit of it in here, and it's sort of mixing in here, as you can see. But it's pretty cool.
I still wonder, when we look at that, there's a hot spot, a red spot at about 10 o'clock and one at about 4 o'clock.
Yeah, these two.
And there appear to be like rays coming from near the white dwarf at the center, running out to those hot spots.
Yep.
That I know we talked about precession when we talked about these the last time. That something is, I would guess, actively happening or was in the near past that is making those two hot spots.
Yeah.
I wonder if it'd be something analogous to if it was a neutron star, and it was a pulsar. The beams of radio or whatever emanating from them. Something analogous to that is what's making those two jets and the two hot spots.
That's a good question. And it could also be that these jets were going this way. If the star was rotating like this, and doing that wobble. I can't get it right. Doing the wobble like you see a precessing top do or something. It could be that. So,
yes.
and so we're seeing like one segment of our history. This moment in human history. These are here. Maybe they migrate slowly over time to a different location as the star might be doing this precession thing going on, and that could have been induced for a whole bunch of reasons, and again, there's no way to really know for sure. No way to know because we haven't studied. I don't think they've studied to see if there was an unseen companion here. If there was, it hasn't been found. It could be a large Jupiter-type planet, possibly, and they just maybe haven't looked at that. And that planet may no longer exist. Yeah, Gladys, the camera goes fuzzy sometimes. So, sorry about that. Alright. So there, that's good. This is good enough for this one. And we'll save it. And save it exactly as seen. I'll tell you, this camera, we're seeing more detail in a lot of these regions here. Look at these little wisps that are now visible that we just didn't see before. You see that, Daryl?
Yes.
Yeah, this is definitely better camera. And once collimated, all the nebulae are going to be much sharper and clearer. Anthony says, sounds like it makes sense. And then there's I can't see because there's an icon in the way that I can't get rid of. Oh well. Sorry, Anthony. I have to wait for another comment to come in so I can read it. So, we'll just do this again, and then we'll be done with this one. Yeah, so this is star death. We just saw star birth. This is star death. Okay, and go back to our night vision mode here. Okay. Let's go. Now, where's that Lion Nebula, Daryl?
It's up in Cepheus.
Okay, let me actually search for it.
Sort of between the Elephant's Trunk and the Wizard Nebula.
Okay. We looked at that before. It was a really interesting set of colors. It was blue and red, and they were kind of mixed together.
If I remember correctly, it may be Sharpless 132.
Okay, because I know that we've seen this before. It's really pretty.
There it is, Sharpless 2-132.
Yeah. All right, and what we'll do now is go into our DSOs, our deep space objects, and we'll bring the Sharpless catalog. Sharpless is another catalog of objects, obviously. And we're going to bring the Barnard catalog in as well. Okay, so let's go to the Line Nebula. I'm anxious to see this with this telescope. With collimation, it'll be even far better, but I'll check it out now. "12 feet tall says, are black holes real? Do they really exist?" Yes, they do. Let's see now. I think I see it here. This may cover the whole view. Let me just go here. Let's zoom in on this thing. Okay, this square represents our field of view, and you have to look at it the way the numbers are, so you orient it that way, and we should be able to see exactly the same thing. So there's that red star. It's showing on the left, and the red star is here, so we're going to move over a little bit more because we're not exactly in the right place. You can see it's here though. Okay. A little more. Hello, Vince Giglio. How are you? This is a ZWO ASI 183 MC Pro. We do one-shots here. We don't use black and white because I don't want to have people sitting through all the integrations of H alpha, O3, sulfur. I'd rather they show them all in one shot. Yes, our JPX, we have photos of the quote-unquote shadow of the event horizon in measure blank.
87.
Thank you. Yeah, Measure 87, a giant elliptical galaxy in Virgo.
And Sag A star.
Yes. Okay. We're guiding. Let's go and let's do a 30-second shot here. And our guiding seems like it's stable, so I'm always on the lookout for wind. So there's Dumbbell Nebula. That's up on the server probably by now. Yeah, I don't think we'll be looking at any black holes, right? Okay, let's color correct. Let me also go back out to... There it is. Let's go and... So this red star is right here. It's on the left. You gotta turn your head. So I actually have it... I have it more here. This is our frame, and this is the bottom of the frame, this is top of the frame. It's actually more like this, so you'll see that the nebula is here, and that red star is right there. And as we integrate further, we're going to see more of this, and I'm going to just try something. What?
I think this is not a very exciting object from what I'm seeing so far.
Well, we have to give it a chance to integrate a little more because there's some density up here.
Okay, and you're not stacking yet either, so
Oh,
proceed.
yes, I am. I am stacking.
You are.
Yeah, but this is just a 1 second shot right here. You see? That's 1 second. I just realized that. I put in 30 seconds, but apparently it didn't take. So now we're gonna do it. This is just 1 second. Now we're gonna do 30 times that amount of time. So you're gonna see a lot different view. I wondered why it wasn't coming in. I went to type 30 seconds in and there was a little delay. By the way, we had an interesting problem occur yesterday. Starlink went down. I've never had Starlink go down before, but the Starlink satellite network was down for a period of time.
Supposedly all over the world.
Yeah, I looked at the outage map and there were hot spots all over the place. Okay, so now check this out. That's a little more like it.
Okay.
Yeah, and so color correct that, right? And now you can see that this is a substantial object. This end is red and this end is blue. See the blue nebula down here? I really need to go over more, so I'm going to do that. Sorry, guys. I'm going to move that over more. Okay, so I'm going to move this over so we can see this.
Trevor at Astro Backyard said it actually looks like a lion. I don't see a lion yet.
Well, we have a higher magnified field, so you may not see a line at all, but we'll see.
That's true. He was, his image was, what was it? 81 millimeter aperture refractor at f5.6.
Okay. By the way, you notice that east is east, west is west, north and south are proper now. You saw that, right?
Oh, yeah.
Yeah, that was corrected. Okay. Because remember, it was on that weird diagonal.
Yes.
Okay, we're going now 30 seconds. Now you're going to see what I'm getting at, okay? And we look at this image here. It's red here, and you see a blue thing here. That's going to be more over here now. We got a diffuse hydrogen nebula here, and then we have a reflection nebula, or this scattering nebula down here. So when I clear this, all right, right now, when it comes in, the red nebula is going to be like here, and the blue nebula will be here. And like I said, it's going to fill the field. This is a large object. There it is. See, the red and blue. And we can do a little more for the blue down here, but I moved the red just to the top. Okay, so let's color correct that. And everything else will stand out more now. There's the red, there's the blue. And let's see if we can get this to pop a little more. I'm sure we can. I'm sure we can. So there you see this, like I said, we did this before, Daryl. It is out there. I just don't know when we did it, but I'd have to look it up in the database. So, and this was Sharpless 2-SH2- what?
2-132.
Okay, thank you. All right.
Michael pointed out Tricia had a question. Tricia, probably not. The comet is presently very low in the morning sky before sunrise. It's pretty much vanishing in the sunrise now. It will be moving to the evening sky in the coming days, but it's after which it will be in the west after sunset. But it will be extremely low in the west and it's really going to pop up and then it's going to vanish and head south. Uh, Mark's telescope won't be able to uh, sight low enough east or west to be able to see it. And I dare say most people are going to have a hard time seeing the comet at all from here on out. It's
Yeah.
pretty much lost in the sunrise right now. And then when it comes up after sunset, it's going to be very low above the horizon for a few days, and then it's going to disappear.
But the telescope can see it, absolutely, Tricia Ferreira. Thank you for that question. It's just that the walls of the observatory are going to block it. Remember when I talked about, if you were here, I said the new telescope is going to have a clamshell. It's going to open up down below the level of the telescope, so the telescope will be able to see all that. That's precisely for this reason, so that we'll be able to see things like this and catch objects closer to the horizon. Astronomers don't like to look at the horizon because you're looking through more air, and it makes images look rougher, more turbulent. But it's okay, you know. And you're in Whidbey Island, okay, in Washington, yeah. I know where it is. So this, boink, is the Lion Nebula, Sharpless 2-132. Let's just move that over here, get it out of the way, so that you guys can see this unfettered. Actually, let me do this. Let me move this, and let's remove the telescope from the view for a moment. Okay, and zoom in. There we go. Look at that. Look at that. That's something. And now I will just go pink and get rid of that. So we can watch Sharpless 2-132 or the Lion Nebula come in. This particular camera is one of the most sensitive cameras of the ZWO line. So we're, in just 30 seconds, we're capturing a lot of faint detail that the other camera could see, but not with just a 30-second exposure. We would need a little longer to see it. So the ZWO is the name of the company. Of the ZWO family, this camera is among one of the more sensitive. So, hey Rocket City Astro, what's going on, man? This is the 183 MC Pro. I think if you asked another question, I missed it. It's not the 2600 or the 533. The 533 has a square sensor, and that's okay. The 183 does too, relatively. In fact, you can see the frame of it by just zooming out. Okay, it's sort of rectangular, but it's actually... it's not a 533, unfortunately. I mean, I say unfortunately. Fortunately. 533 is a good all-around camera, but the 183 MC Pro is better for what we're doing. And what I did was I had figured out the best arc second per pixel resolution value for this telescope setup at f2 and the camera. And I went through the calculations to figure out which one was the best one. This one is really close. We're now in a range that's actually not excellent, but good. The 294 MC Pro was only fair for this particular setup, and still we came out with some really miraculous shots. The benefit of this camera is that we have over 5,400 pixels across, and like roughly 4,000 down, and so that means that and the view is smaller, so we're having a tighter field of view with more pixels. So what that means is more pixels can be used to represent the objects we're seeing. That translates to higher resolution for the sensor, and that's what we're seeing right here, and it's really pretty. Now, I noticed some pictures before of the Line Nebula. You notice how this looks sort of green?
Yes.
Yeah. That was something that was interesting because when you look at it, it looks green to me, and I would equate that with ionized oxygen. But I saw other photos showing it as blue, as a reflection nebula. And I'm not sure whether, because I haven't researched it, I just love the Line Nebula, so I looked at it that way. Thank you for the suggestion, by the way, Daryl.
Yeah.
Yeah. Yeah.
It's all right.
Oh, it's really pretty. It's got a lot of complexity in here.
If you look at the top of the blue-green area, there's like a dark line, squiggly line
This?
running along the top of it.
Oh, up here.
No, closer to the top of the green area. It's sort of dividing between the green and the red.
Oh, up here?
That general area, a little farther down,
Oh, like
you can
here.
follow that dark line down over on the left.
Like this?
No,
Okay.
I wish I could put my
Wish you
cursor
could
on
draw
your
it. Yeah, I
screen.
know. I'll work on that. That might be possible.
Well, as usual, I see dark lines,
Yeah.
which or they tendrils of cloud. I've wondered before if they're real or if they're just artifacts of the image. They appear to be real.
Hmm.
There's a pretty clear, thin, dark, wandering line between the top of the green and the bottom of the red areas.
You talking about this thing?
That's just a very small part of it, yes. Over to the left, it angles down to the left a lot.
Yeah, I don't
Right
see
there,
that.
you just went right by it.
You talking about this?
No,
Okay.
right there.
Okay.
No,
Right here?
right there. There's a dark line going down right there.
Right here.
Yeah, you don't see
Okay.
that?
I do.
And it kind of meanders across the top of the green area and over to the right. Michael
Okay.
says he sees it.
Mm-hmm. I've always liked
Anyway.
the Line Nebula is really interesting to me because of these things. I hadn't seen that little tendril there, but I do think that's actually rather interesting. Quite a bit, actually. That's a fascinating little area. How many have we stacked here so far? Let's go check it out. We've stacked 19. We'll go to 20. We'll do one more. "12 Feet Tall" says, Rocket City Astro says, there is software to count and remove stars. Yeah, we actually use that star removal technology every time we process. So that's something that's really interesting to do. I could always, I have to put together a class on photo and video processing, so I'll probably put in star removal as well. Cosmic ray, it's dark cloud ray. It's dark clouds here. Go ahead. What'd you say?
Izabela is sending me her processed image from when you shot the lion before.
Oh, that was a long time ago. Yeah.
Said she's
Right.
going to send it on Skype.
Very good.
Perhaps you'd like to
Okay.
show it. Here it is,
Yeah.
right here. I'll have to get it over to you.
No problem. I'm just gonna wrap this one up. Okay, so this is the Line Nebula, Sharpless 2-132. So we'll save this here.
Oh, wow. Yeah, you need to show this, Mark. This is really good.
Okay.
Uh,
Now, what Daryl was talking about is the processing. Let me get my telescope back here. Move this over. There we are.
Thank you, Izabela. That's really beautiful. I think I do remember this, now that you mentioned.
Yeah. So the thing is that these objects, this object is something that all the data is in this image that you're about to see. Okay, we're capturing all the data, but it's just not immediately available without doing some processing. And I think Daryl's sent me the image. And there it
I have
is.
it.
Yeah, yeah. Oh, that's pretty.
You have it?
So this, I have it. I'll be putting it up right here. Okay. So let me come over here and put it up. And so here is the image. Wait a second. That's not the image. My mistake. I will get the image up.
I assume you're getting it from our group chat too.
I did, yes.
Yeah, okay.
Yeah, I just have to.
I know in the
that's right.
past you
I
would
gotta bring
send
it
it
up.
to me and I would drag and drop it over to your chat.
Yeah, yeah. One moment, guys. Everything's gonna go away for a second. Everything's still here, though. I am going to. Let's see where this is. Is it this? No, it's this. This? There it is. Okay. All right, you ready? Well, too late. It's already there. Yeah. So that right there, that's the image.
I don't see anything.
No, you don't, because your screen is being shared. You're not seeing the broadcast. So that's what we're looking at. So when we look at
I see that.
yes, when we look at this here, okay, that right there has buried within it all of this other beautiful imagery that you see right there. Okay,
Can you
so
go
that's
back to her image again?
I did already. It's up on the screen
Yeah,
right now.
right there. Okay, I see it now.
Yeah.
I kind of do see a lion in that.
Okay.
It's his front leg at the lower left. It's his head at the upper left.
So
He's got a big round butt over on the right, and
and a big round butt there. And what's this? Is he been squished by a car? I don't get it.
that's his front leg.
This is?
No, the red
This
thing,
is.
the red arc over at the lower left.
This here.
That's his front leg.
Okay, you're looking at it on the stream right now. You're not looking at it. You're seeing a delay.
Well,
Okay.
sorry, that's the only way I can see it unless you got it up.
Yeah, I have it up live, but you're getting a window shared, not a screen.
Well,
which
it'll be that way.
I can change that actually. Yeah, that's pretty. It's really pretty.
Izabela's image, I see the head at the upper left, front leg at lower left. Looks like he's got a big round butt, and then his back leg is at the lower right.
Okay.
Gladys says a pregnant lion.
All right. Well, let me do a screen share. That's going to be a little better for you, Daryl. And that will be.
I can see it fine on the.
Actually, this won't work. Okay, so we'll leave it at that. I can't do it for you. You're going to have to just. You have to see it that way, unfortunately. All right. Awesome. All right. Well. So there you go.
Well.
I know, but it's okay. You saw it. Okay, so people got to see just what it was. And that's cool. Really pretty. And that's what we're taking a picture of. So we've done 31 frames here. More than we did in the last image that you just saw. So we're going to save this as 31 frames. And then save exactly as seen. Very pretty. That's way up in the north.
Since we're in the neighborhood now, could we look at the Wizard Nebula next?
I was just thinking the same thing. Absolutely. Wizard Nebula is right nearby, actually. Maybe these are part of the same complex.
Uh-huh.
Okay. So we back out of this, and you'll see right here we have the Wizard Nebula. Which
Yeah.
I'm going to go from here down to here. So we also have the cave, which we're going to look at next after that.
I like the Wizard. It always reminds me of an old Uriah Heep album cover of a wizard.
Okay, so the Wizard Nebula is going to be here as well. I just have to... Let me get all the way back out. Alright, and I think I'm going to have to go westward again. Because there it is, right there, I believe. Alright, there's the wizard right there. Alright, so what I'm going to do now is just do a alignment. Alright, great. So it's all grabbed, got the alignment done. Let's do, now that we've got our guide going, we're going to do a 25-second shot of the wizard. And go check it out. And remind people of the Lion Nebula we just saw, which is right here. This is a deep, rich, beautiful region of emission nebulae. I will check on whether that's a reflection nebula or emission. I think it looks like it's a O3. I'm not sure if this was a supernova remnant or not. I have to look that up too. Part of a mix. There's the wizard. Look at that. There's the wizard. Pretty. And let's color correct this. It's a little bit blue. Okay. Yeah, the wizard is pretty.
Are you sure you're looking at the Wizard?
This is the wizard right here.
Can you zoom in on it a little bit?
Well, remember the star problem. When I get more integrations, I will. See, there's the wizard, and there's your little girl. I mean, all the parts are here. This is your little girl. Here's your wizard with his arms. And the hat. Remember?
Okay.
We're at
barely make
25%.
out the
It's
little
really...
girl.
Yeah, I know. We're zoomed out right now. There's a new filter out by Opto-Long, which is one that promises amazing views of nebulae like this. The only problem with it is that it's no good for galaxies. And when you're remote, you've got to be able to hit every object,
Yeah.
Because our camera's on the front of the telescope, but for the next telescope camera, we're using a filter wheel, so we will be able to do all the things we want to do, and have both filters like this one in there, and then the other special filter that will enhance and show the objects even better.
Yeah.
So we can do both.
I think I sent you the link to that filter In fact, I know they said it was good for mission nebulas, but not good for galaxies.
Yeah.
Oh well.
That's all right. All right, I'm just looking to see what we got in here. 12 feet tall. I don't know what a gravity telescope means for what we're doing. Zoom in a little. See? Here's your wizard. There's his outstretched hand. There's your little girl. The other arm is here.
Right. And it's like he's got the big bell sleeves. I see it now. I don't make out the girl very well.
Well, she'll come in here as soon as we get some more integration. She'll be pretty clear.
Yeah, because it's like she's reaching out her hand to him, and he's reaching out.
Here, yeah.
Yes, he's reaching out his arms toward her.
Yeah. Yep. And there's his face right there, and you can make him anything you want, you know. Let pareidolia build you a picture.
Oh yeah, it is. I have Uriah Heep playing in my head now.
All right. Yeah, it's actually a rather calm night out there. I'm watching our guiding values, and they're actually staying within the limits pretty well. All right.
We could show you a heart, 12. The heart's not far away either, I believe. And that reminds me, Mark, I sent a link to our group chat a day or two ago. My sister had shared with me, they had a web image of the elephant struck. Did you see that?
I did, yeah. I did. I'm telling you, I wish that... wish I remembered that. I would have put that up, but with all the, the dark screens and stuff, I have to prepare that ahead of time. I wasn't prepared to show something in Skype tonight, so I ended up kind of cobbling it together on the fly here.
No worries.
But you can see the wizard is starting to look better. And keep in mind that when our stars are not, if stars are slightly out of focus, keep in mind the nebulae are too. But still, it doesn't look bad, does it? If we zoom way in, you'll see the issues we're talking about. There, now you see them.
I can see the head of the girl, and I see her arm.
Right there and right there.
Crooked elbow right there, yeah.
Yeah. Now, but people, you can see the donut shapes, and you might say, "Oh, well, just focus." It doesn't get any better, because if you go now and try and focus, what ends up happening is they go wonky and they grow this halo, and that has to do with collimation. The collimation on the system is off. But if we stay at the 50,000 foot level, basically, and look at it from a distance, you can still enjoy the beauty of it. And after next week, I'll have those as sharp pinpoints. I'm going out Tuesday through Friday of next week. Holy cow, that's not too far away. But what's interesting is, because I have a spot to land out there for a Sky Tour, our 501c3, I already have many sets of clothes out there and suits and stuff like that. So that becomes the base of operations. So I'm going to get on the plane with nothing but just regular clothes. I'm only going to bring a charging cable for the phone. And I won't need luggage of any kind. So when I get there, all the stuff I need is out there. In tools as well. So this is going to be nice. We can do the heart. And it might be within range. I don't know, though. It might be low. Let's go see.
Heart's in CPS too, isn't it?
Yeah, but I'm looking down here. It's 7822, and yeah, it's kind of low right now. See, heart and
Oh,
soul.
okay, it's not CPS. Never
Yeah,
mind.
that's okay. But we are gonna go look at the cave after this. All right, the cave is actually really pretty, and that's right here. All right, so this is the wizard.
Thank you for showing us that.
Yeah, no, it's all right. It's a great idea. All right, that's the Wizard Nebula. We'll go to 20 on this, and you can see it's obviously more detailed. Once these, like I said, once these are perfectly once it's perfectly collimated, it's going to be a lot better. Anthony DeSanto says, "This sounds great. Do you ever give any tours of SkyTour?" I wish I could actually. I have inquired in the past, but it's on protected land, and even I, as the creator of all this, with Marianne and Tara, and of course Daryl helping out with everything we do. It's I can't just go there whenever I want. I've got to plan and get all the proper permissions to get on the land. All I can say this observatory is probably one of the most secure places on the planet. I don't have to worry about any of that stuff. I have to worry about tarantulas more than people. You know.
And the owner of the property is heavily armed, is he not?
There's a shooting range on the property, yes.
Yeah.
I
wish I had a shooting range.
I have no problem whatsoever. And he's not the only one either. There's numerous folks out there on the property that also protect it. RJP, no, it's not reservation land. Although I've been invited by Navajo, actually, to go out and on their land. My mother was Native American and Irish, and I was invited to go out on Navajo land to look at some of the very interesting goings-on that happen out there. And my friends John and Stan, the Navajo Rangers, extended that invitation. And at some point, I will take them up on that.
There is an old fella on YouTube who is he's like an elder of the Navajo Nation.
Cliff Mahooty.
You know who I'm talking about?
That's Clifford Mahooty. He's a Hopi. He's not a Navajo. He's an elder with the Zuni elder. I mean, Zuni, and he passed away a year or two ago, actually. But he was a good friend.
I think that's who you're talking about. The same guy. This guy said he's Navajo.
Okay. Then
he sure seems to know a lot about the Navajo if he's not a member.
Well, then I'd have to see his picture. Renee Barron's in the chat. She's also Native American, indigenous as well. My respect to you, Renee. I got to meet Renee and her daughter Alicia and granddaughter Darlene and Donovan, Alicia's husband. And they are very nice people, all of them. And it's a privilege to know them.
I guess what I was going to get at with this guy.
Yeah. Sorry.
He says a lot of really interesting things about the Navajo culture and their history, and gets into their mythology, I guess you'd say, for want of a better word. He talks about the Anasazi, and he says that we have it wrong about the Anasazi. The word means ancient enemies, which is pretty common. But he said in particular that the cliff dwellers were not Anasazis. They were, the Anasazi came up from the south. And I've seen other corroborating stories about this, that they came up from the south, and it gets pretty dicey. The natives, Americans, don't like to talk about some of this, but where the ancient enemies thing comes in was some pretty bad things happened down there in the past a long time ago.
Yeah.
And their culture, they still remember talking cannibalism, stuff like that.
Mm-hmm.
He said that the cliff dwellers were not Anasazi at all, but they were like the enemies of the Anasazi, and the cliff dwellers were actually part of the same culture as the Navajo.
Okay.
You know, Mesa Verde and stuff like that.
Sure.
Chaco Canyon. Anyway, he's an interesting guy. If I ever run across him again, I'll try to remember to send that to you.
Yeah, please do.
He's an interesting guy.
All right, we finished up with the Wizard, and now we're going to go to the Cave Nebula. The Cave Nebula is far more complex than the Wizard in some respect, and you'll see why. There's a lot going on in the cave. There's a lot of interesting objects in the cave that we've seen before, and they're actually all worth talking about, but we're not going to. I think we should. I hope I can look at the bubble in a few seconds. The bubble is actually pretty cool looking. All right, so the cave should be right here. Yeah, I'm gonna just jog it a little west for just a minute here. I haven't looked at the bubble with this new telescope camera either, so the bubble is going to be a sight to see as well. Okay, let's do that. Alright, 25 seconds. Actually, I can just put in 25,000, that's milliseconds. So 25 seconds, and we should get, there's our Wizard from before, and that's pretty. Okay, so that's up on the server by now. And next is the Cave Nebula. You don't have to be sorry going off track. It was fine. It's a great discussion. One of these days on Skytour Radio, we should talk about native lands and the native mythologies. Let's do this. Let's back out. Let's go to 25. Okay. We're going to keep note of these objects down here that I'm circling right there. Those are called Herbig Harrow objects. Keep an eye on these guys. Keep an eye on this wall up here. Alright. As well. And this black nebula. So, in other words, look at all this. Alright.
Native Americans, their history and the tribes and stuff have always been of interest to me. I probably paid more attention to the Plains tribes than I have to the desert Southwest.
Well, most people have. Most people don't even know there were Northeast New England tribes. You know, because they're not.
Sure.
They're not as dramatic. You know, it wasn't as dramatic. The last of my mother's relatives live at like Pleasant Point, Maine, is the far off in the northeastern United States as you can go. Shove them all into the corner. You know, which unfortunate. I actually want to go. I really do want to go visit up there just to, you know, talk to some of the folks that still live up there. But you know, most of them are assimilated into society. They have names like Frank Jennings and things like that. You know, They're not like what you would expect. Look at this. Look at it. See how complex this is?
Yeah.
I wanted to go. I had to put this higher up so we could get these Herbig Haro objects in here. These objects are beautiful. Herbig Haros are young stars that have winked on in the recent past.
The Herbig Haros, they are still embedded in their parent clouds, are they not?
Yeah, that's what makes them so interesting, is because they illuminate the cloud in a very interesting way. For sure. C&D Boy, thank you for that interesting information of First Nations. And thank you for your kind words. A lot of people have ancestry that some realize it, some don't even know they have it. I was fascinated and also had to pursue a lot of it. In fact, I pursued my native history for a long time just to kind of understand more about the Passamaquoddy, which is what my mother was in part. Now they have a casino up here. You know, so they can take back from America what America stole. I don't grudge them that. I don't begrudge them that. See the Herbig Haros now? Look at that. They're showing more detail than we've ever seen here, Daryl.
Uh-huh. The image is really shaping up.
Yeah, we got some pillars here showing up. Okay. Here's that area I told you about to look in. Look at this little bay in here where young stars are causing this gas to glow in here. There's a dark nebula over here.
Yes, I was just looking at that.
Let's see if we can... Okay, there's a softer view. And I did that so you can see one other thing. If you look here, let's zoom in on this little section here. Okay. Notice this area right here. You notice how it doesn't look like it's dark like this. It actually has sort of a bluish hue to it. That's because it's a dark nebula. Dark dust is what a dark nebula is. But that dark dust is scattering the blue light from a star that may be within the cloud that we don't see, or it might be one of these stars. I'm not sure. But that scattering causes a mix of the blue color that we see with the scattered nebula colors, the reflection nebula as we call it, and the dark dust sort of mixed together to form like a dark bluish gray. Alright, so this is actually a color that's really there, because we're seeing a mix of that blue nebula mixed in with the dark nebula, which are not part of the nebula not doing any scattering.
The dark nebula on the right is it's very complex.
Barnard.
A lot going on in there.
And I think this has got its own Barnard number. I'm not sure. I think it is. So we can zoom over a little more. See? You can see there's a lot going on here.
Now, there's actually some fine detail down inside there, too.
Yeah, you can see it. It's showing up. Now we pump this one here, and you'll see more of what's going on. We're not going to leave this on here, but just to show you what's actually going on in here.
Right.
That's more data. There's more data here, as you can see,
A lot
hidden
of
in the background.
fine dark tendrils in there, too.
Yeah, I know. You're right. So now we'll go back to this guy and try to coax that detail out by using less than a shotgun approach. So we'll do this. What I'm doing now is something called push processing. Push processing, here we go, look at that. Push processing was done when things were still being done with film. You could push an exposure to bring out more detail. But when it was film, you had one shot. You know, unless you made several shots of the same thing, you only had one shot. Look at all this detail. Notice now, remember I told you about these two stars here and this nebula down here? Remember it was just a sort of a hazy nebula? Now after 18 stacked images, you can see this is actually like brushed, like a brushed look to it. You actually has this separate lines of nebulous streaks here. So that's what happens when we see when the stack takes over and you start to see more detail. See the streaks? You see
Yes.
dark and light, dark and light.
There's a bright star right next to another one down there in the lower right corner, and it's got, looks like reflection nebulosity around it.
I was just talking. That's what I was just talking about.
Yes.
And that's the streaks. That's the brushed look, right? I was telling you about.
There's
Like
a bright reddish star a little bit to the upper right of center, and one of the 10 little very narrow dark filament right there is pointing toward it.
Yeah, that's this guy right here.
Part of a larger set of filaments.
Yeah. And keep in mind, guys, these
Lot
filaments are
going
all
on in there.
in the foreground, and the nebula's behind, and they're blocking the light from the nebula behind it. There's more going on behind this cloud too. All right, this is all dark nebula here. Dark, and again, I can't impress upon you enough how many supernovae took place in our galaxy in an ongoing way to create all of this dust from whence we come. And that's why when we say you are made of star stuff, it's absolutely true. You are truly made of the material that was formed in the hearts of a star at one point. This is really pretty. Look at this, Daryl, man. I'm telling you.
Yeah. It's really something.
Yeah, this is coming out great. Alright, this is 23 exposures. And we're only doing 25 seconds. Can you imagine if we did 4 minutes or 3 minutes per exposure? It would just be stupendous. But no one wants to sit through 4-minute exposures. I might do it privately. Or 2-minute exposures. I might do it privately, you know, just to see. But this is really pretty. And again, this is now a birthplace of more stars and more nebulae and more planets. When I say more nebulae, because undoubtedly there's some big stars in here, the ones that are illuminating or causing this hydrogen to glow, which may go supernova someday, possibly. And when they do, they're going to litter the cosmos with even more material. What's that?
25 second exposures is 625 seconds in effect.
Yeah, it's 10 minutes, 25 seconds. But it's only 25 seconds. It's 25 second stack. A 2-minute stack of similar number of exposures is going to show way more detail.
Well, sure.
Yeah. So we're doing a 10-minute. We've done this 10 minutes, 50 seconds so far. That number is right there.
You call that integration time, I guess.
Yeah, it is 11 minutes, 15 seconds. But our exposure length is 25 seconds. So you're never going to get what you would see with a 10-minute exposure with a 25-second exposure, no matter how many you stack. It's just going to be clearer and less noise. So that if there's a faint nebula that can only that's like, at 18th magnitude, and you can't capture it at a 25-second exposure, but you would say a 10-minute exposure, then that's the kind of thing I'm talking about. You'd see way more detail with higher exposures. Stacks don't give you more detail, they give you clarity and clearer images. That's why the first one was grainy, and now look, this is stunning.
Yeah.
Right? Now we can actually zoom into this area up here. Again, forgive the stellar issue. And you can see the clouds with all the complexity in here. Look at the filaments here. This stuff will all be
RJP
clear.
asks if that's a bow shot going on in that bright red part.
Up here, maybe?
Somewhere along that wall right there, yes.
Yeah.
Of the whole thing.
Maybe. If it is, I don't know the star that's causing the ionization here. It may be inside this nebula somewhere. We may not even see it. It could be this star or that star. It could even be that little star right there. I mean, it depends the relative location they are to each other in 3 space. Because again, it's a 3-dimensional universe. So this star might be very close to this wall, and this star might be very, very far away. Even this star could be very, very far away, much further away, say, than this star. This one could be way in the foreground, and this one could be way in the background, and just have the same relative brightness to each other. Because you can't use brightness of a star to gauge how far away they are, or how far away they are relative to each other. Because they're all different sizes, and different sizes correspond to different luminosities, and that is intrinsic brightness. So, wow.
Oh, yeah.
I'm liking this.
Like in the case of North American Pelican Nebula,
Yep.
the stars that are lighting up North America and the Pelican are actually hidden from us behind the big dark cloud that's in between the two objects.
Mm-hmm. You have spoken wisely. So we zoom out now, and you see the whole image. Okay. There's the cave. That is just stunning.
That's very nice.
Yeah. Yeah, even with the collimation problem, it's very nice. I'm okay with that. And pink. There you are, Cave Nebula. Now it's labeled. Okay, well, this is 34 exposures. Izabela and I will probably have a ball with this doing processing. And after we collimate, we're going to do this again, whether private or public stream, and it will be something. So there's 35. We got the name Cave Nebula.
I have a question before you leave.
Okay.
Can you possibly drag the image to the right, or is that full size?
This is the right-hand edge right now. You want me to go to the right?
Well, I was
size.
wondering what that is on the left side.
Oh, that is amplifier glow.
Oh,
That white thing. There's no star there.
Yeah.
That's amplifier glow.
all right. I was thinking something might be bright over there.
Yeah.
Okay,
No.
never mind.
Yeah, it's okay. I wish it wasn't there, but it is. Consequence of using this. And we get rid of that. The way you get rid of that is with what are called dark frames. And when I get out there, what I might do is I might do a set of dark frames where I just do a bunch of dark frames, and I'll have a master dark frame, and I can just always subtract that from all the images. And if we look down here, okay, all right, I'm applying a flat right now. I did a flat frame, which gets rid of a center brightening that's characteristic of all these sensors. And you see the dark frame, I could have a master dark right here, over there on the right, okay, where my cursor's over here. And I could actually do a subtraction of a dark frame automatically in the process, and that's something that we're going to do but I got to be there to do the dark frame. But once I do a dark frame sequence, that'll be great, and then all these glows will be removed automatically.
We found the Navajo guy.
You did? Okay, hold on 1 second, please.
He tells a lot of really interesting stories. Hmm?
Sorry for the delay, folks. That's okay. It gave us more frames. Okay, we'll just save that too, because that's just beautiful. All right.
It is that.
It is, yeah. Okay, so we'll clear that. Tell me about this Navajo guy. What was his name?
See if I still have it open. The channel's called Navajo Traditional Teachings.
Oh, I know that guy.
Yeah.
I know who you're talking about now. Yes.
Old fella. Bonnie
Yes.
put a link up in the chat.
And he also does language tutorials on Navajo as well. I've actually been learning Navajo language, believe it or not. I have a class study I'm doing on it. It's really fascinating because I'm not. I speak like a 1-year-old. I'm not even anywhere near. So I can't do anything good with it yet. But when I do, I'll say some things and talk about it. We're gonna go to the Bubble Nebula right now.
Okay. Would you excuse me a moment, please?
Sure thing. Go ahead.
Good night, Renee.
Renee, thank you for coming along. All right. That delay earlier was because we were wondering if our youngest son was home from work. He works at a TV station in the state. And he was actually at the Mohegan Sun Native American Casino tonight. That's why he was there, but he was covering it for the TV station. Okay, that right there is the object of our quest. That is the Bubble Nebula. And there's a lot going on here. We're going to move this over and center it up. There's a cluster up there that I'm going to bring into view as well. I think you're muted, Daryl, but maybe that's you want to be. I'm not sure. Okay. All right, let's now do... Let's do a 25-second shot here and show you all the complexity going on out here once we get our guide star. Here we go. I can see actually that we have wind. You see that? Oh, we got a whole vertical line there. Oh yeah, we're getting lots of wind right now. Okay, well, let's move a little west and see if we can move out of the line of sight of the wind a little bit. Anthony DeSanto says, you always mention a guide star. How does that work? Excellent question. The telescope sitting right there is obviously a big barrel. You can see it nearly. But on the other side of it, out of view, is a really powerful wind right now. We're going to wait this out. On the other side of it is another telescope that's mounted parallel to it on top. And that second telescope is actually a guide scope. And I could show that to you, actually. Because I have its brother right here behind me. Alright, so I'm going to take away the transparent background on my camera and enlarge just a little bit. So I want you to look back there. And let me change the lighting a little bit in the ship here. Alright, and so when I do this, what I'm going to do is, let's see if this is, that's not that light. Is it this light? Yes, that's the one I want. Oh, sorry, I don't have to do it that way. I can just change it to this. There you go. Okay. You're welcome back, Daryl.
Thank you.
So, the barrel of the telescope looks like that we have. And that scope on top, that's the guide scope that you're seeing. And we have the same setup out there, but that guide scope is on the back side in this image here that you can't really see it. And so those two work in concert together to bring you, to bring this all to you. Okay, so what I'm going to do now is just take that off, get us back to this. Okay, so there we are. All right, so we're having an issue with the wind, actually, and it seems like the wind's still kicking up. You see that? Every now and then we're going to get a wind that comes through, and see, that's like pretty bad right there. Keep in mind that telescope barrel is actually like a gigantic flag waving in the wind. So we have to kind of let things calm down when this happens. And if you watch our numbers, okay, 3.4, see that? That's bad. 0.4, 0.8, great. 1.8, okay. 1.9, okay. 2.9, not good.
As Ray likes to say, you need to invite that spider to come back.
Well,
Spin a web we can watch.
Yeah, but you can
It's like
just
your
watch the numbers.
windsock.
Well, the numbers are a windsock too. See 3.0. You know, it's actually getting pushed around by some desert breeze right now. 2.8, 3.1, 1.3. Yeah, you know what? I'll tell you what. We're gonna try it anyway. It's not gonna come out well, but we're gonna just do it to see what is out there in this nebula, right? This whole region. So we'll live stack it regardless. So the last one that was the cave, look at that. Oh, that's just beautiful. Wow. I can't wait to process that, even with this working like this. This is great. Anthony says, I understand the guide scope, but how does that help you to find your image? Oh, see, that didn't come out so bad. Anthony, what happens is the telescope is aligned to the North Celestial Pole. And that alignment allows us to make it so that the telescope knows where it's looking at any one time. And our telescope is set up so that even if it gets lost, let's say somebody bumps it and moves it like 40 degrees, we can point it anywhere in the sky, and it can figure out where it's pointing by looking at the pattern of stars and solving the position in the sky it's looking at. That's called plate solving. And we get the size of our field of view and everything from this, and it's really cool. Izabela, this is the Bubble Nebula, one of your favorite objects. and we haven't imaged it and in the past too much, and I don't know why. But I think we did, but it was small. This is actually already pretty big, and if you notice, we'll be able to zoom way in on this once see that we got the wind causing our stars to go kind of vertically lined up there, and they drag out. But look at this bubble. This bubble is caused by this star right here, and then this side is very different looking, and this side has been has been able to expand out into the interstellar space fairly uniformly, but this side has been disrupted. This is the edge of a molecular cloud in all likelihood here. These dark nebulae are part of this, or they're kind of interfering with the view. And this is it's called the Bubble Nebula because the star has blown a bubble. This is a star called the Wolf-Rayet star. Wolf-Rayet stars are very, very hot, and they will do weird things like expel their outer atmosphere. Remember we talked about a star made with the elements of different kinds in the outer atmosphere. The core, that little marble in the middle, is where the nuclear fusion's happening, but the outside is the plasma, the protons and electrons that are very, very hot, that are just there for the ride. Well, that's happened here too, except that this particular star, for reasons that aren't really well understood, has blown off its outer layers in a fairly cataclysmic ejection. Maybe not just one, but multiple times. And this is a particular family of star that we call Wolf-Rayet stars. And these Wolf-Rayet stars is a variety of kinds, and they're characterized by the spectrum they give off. And so this is one of those anomalies that we see in space that I think that bears a lot more research, and there's a lot of people working on Wolf-Rayet stars. There's a lot known about them, but there's still a lot more to learn. So it's actually a fascinating topic, and one that we probably should also cover in SkyTour Radio, Daryl.
We have before, haven't we?
We have, but we didn't talk about all the different types.
Oh, well, they're extremely bright also. That star there, you're probably talking on the order of 500,000 to 1,000,000 times brighter than the sun.
At least. Okay, I'm going to clear this image, and let's see if the next one... Yeah, we still got wind. That's too bad. There's a lot going on in here. When we pump it up to overdrive, you can see there's more stuff going on.
Gladys, they are relatively rare. Their number, the number is only run up in a couple of hundred, if I remember correctly. Up in this part of the sky, the general area of Cygnus and Cepheus and Cassiopeia, I guess I believe there's several right in this one part of the sky. Aren't there, Mark?
Well, I mean, we have the Bubble Nebula. We have,
Crescent?
Yes, thank you. I was trying to think of the name. The Crescent Nebula, and later on in the year, we'll see Thor's Helmet, which is another Wolf-Rayet star.
Canis Major, right?
Yes, that's right. And all right, I'm trying to capture a moment where it's actually good. It says I saw 2.8, 1.2, 1.9. Okay, this image might be okay.
Wolf-Rayet stars are prime supernova candidates too.
Yeah, they are. This might be a good exposure. Must have, before I cleared it and didn't look, it must have gone off the rails. Oh yeah, 3.3 there, yeah. Okay, this one's not going to work tonight, so we'll get out of that and not waste our time anymore on it, but we will get the Bubble Nebula when we stop getting wind affecting us.
Yeah.
At a
It's
certain
like the
time,
scope's almost straight up.
yeah, it's a real flag waving in the wind. Keep in mind that one of the things that we can look at, and I'm going to actually try this now. Here we are. Okay, we're going to try this. All right. Let's see if we can look at the Andromeda galaxy. I think we can. All right. Andromeda is with us. And the Andromeda galaxy is going to be stunning, but of course, as you can see, we've also got wind here. Our galaxy has the winds. Wow. Okay, I was saying before, in the desert, what happens is, after sunset, what'll happen is the wind kicks up off the desert as the desert begins to cool, and you get this rush of wind across the desert floor. This happens a lot. So, if it wasn't 1:30 in the morning on the East Coast, we'd wait it out for 20 minutes, 30 minutes, and that rush passes, and you have a clear night thereafter. So what we're going to try and do now is just do a quick 25-second shot here. See if we can capture the Andromeda galaxy. We are guiding okay right now. Oh, and then I said that. Okay. Let's wait. Well, nothing ventured, nothing gained. I believe that we are... Yeah, let's do the live stack now. Okay. And we'll do 25 seconds. All right. Now we'll clear it. Anthony DeSanto, yes, in terms of large, fully formed galaxies, yes, the Andromeda galaxy is the closest one to us. And we would not consider... look at that. Look at this field, Daryl. Wow. That's crazy. With the other telescope, we nearly get all of it into view, but with this one, we can't. All right, I'm going to clear this one in case the next shot comes in well. Okay, that's better. So, I'm going back now to Anthony's comment. Where'd it go? Oh, yeah. So as a fully formed galaxy with its own spiral arms and dark nebulae, well-defined nucleus, Andromeda is the closest neighbor to us. It's just over 2 million light years away. But keep in mind, we have 3 other galaxies close to us. We have the Magellanic Clouds, all right, which are external to our galaxy. And then we have this dwarf galaxy as well that may also be near us as well. And so we're talking about a fairly close set of neighbors, all right? And Messier 33 in Triangulum, the Triangulum galaxy is also one of those that's close to us. It's just over like 2.7 million light years away, and it's near Andromeda, physically in the sky. and may have been affected by it. There may have been the gravitational interactions. Looks like Andromeda is not working out either, guys, unfortunately. So we will come back to that later in the season. All right. Yeah, we got a lot of wind right there. Well, I suspect we're going to have lots of wind now until we actually see Triangulum Galaxy's down there, but it's going to be too low for us. Oh well. Let's go and try.
Nobody ever looks at Lacerda.
I know, isn't that true?
See Lacerda over there on the right, folks?
I'm looking right
Just
at
went
it,
out
yeah.
There it is.
It's right here.
Yeah, that's the lizard. Lacerda the lizard.
Yeah, well, Lacerda, it just missed out on having the Cocoon Nebula in it. By definition, it has a few clusters. It has... And the Wizard Nebula just missed out on being in there. This H2 region, 7235, missed out on being in there. And Lacerda only has to its name a brighter galaxy known as the Deer Lick Group. We've looked at Caldwell 30 before. And then this Sharpless region, which is a LBN 428. That's a large, bright nebula. Catalog. Lund's Bright Nebula. All right, so that's not working then. So we're gonna end up coming back, pulling away from this region of the sky, and we'll do. We'll try this. Ray's favorite. We'll try a segment of the Veil Nebula. Although I don't hold much hope, because right now that's going to be sticking up even higher in the sky than Andromeda. So we'll just look at the screen, see what we get. And if it's just too windy, there it is though, look at it. Oh yeah, look at that. Oh, yeah, we got wind.
Sure do.
Yeah. Okay, well, the wind then is effectively shutting us down for tonight, guys, but that's okay. Once the season matures and gets a little further along, we'll be able to see these things long after those desert winds calm down for the evening. I don't like to have to make you wait. Okay. So, like, for instance, if I want to do a 25-second shot of this, I can say, well, we can try it, and we'll try it right now. But unfortunately, it's going to end up having a blurred set of stars in it, unfortunately. I did this before. Why did I not do it? Okay. So, 25 seconds.
What are we looking at? The veil?
Yeah, the Eastern Veil. For Ray. It's for Ray. Ray's favorite object. Cosmic ray.
I think
When
Ray
I'm out
left.
there, yeah, I'm sure he did. So when I get out there, I'm going to make sure I encourage a spider to put a web in front of my cameras again.
Oh.
Yeah, see, the veil is beautiful, okay, but unfortunately the veil is also subject to wind as well. But you know something? We had some great views tonight.
You
and
did.
we did. So it was very nice. I want to say thank you to you guys for coming out and spending this time with us. SkyTel Livestream is a nonprofit organization. We depend on folks like you. So, again, hey, become one of our patrons like these folks did. And, there's monthly benefits. We're also working on products for each tier. So if you subscribe to us for a month, if you're in there for 2 consecutive months, you get a product which we're figuring out now what we're going to send out and get for you. It can be as small as a refrigerator magnet and as large as a mug, I think, with one of our favorite objects on it. So, so give it a try. Also, check out all our products in SkyTour Shop if you like to just get something outright, or go to SkyTour Live right here and check out all that we have to offer, from actual photographic prints that are massive 40 by 60 prints if you want on canvas or metal, all the way down to little 8 by 10s framed under glass. We have it all out there. Or if you want to just go visit our server and download the images you saw tonight, they're out there right now, and that's at skytourlive.org. But guys, thank you for coming out, and thank you for spending this time with us. We're going to go for tonight, so we will see you on the other side. So good night, everybody.
Good night, everybody.